And good morning, everybody. It is May Day. So here's the thing. On May Day, you're supposed to go and give flowers to your mother or to your girlfriend or whomever. But May Day is all about getting flowers. Pick wildflowers. Go get them for your mom. So anyway, today, so I want to let you guys know we'll have a test Tuesday. And that gives you next week. Next week, that would give you Wednesday, Thursday, and Friday off if you get it done. If you're behind, it gives you Wednesday, Thursday, and Friday to get the work in, okay? So don't get behind, get the work in, okay? Let's take a look at today's homework. This is what you guys have. So if this is a rhombus, the only way this could be true, the diagonals would be equal, is only if it's a square, and it's not always, so say sometimes. So 2, this is always true. If it's a rectangle, this angle will always be equal to this angle. Okay, those are parallel lines, so that those two angles will always be equal. 3, if it's a rhombus, that's going to be 9. 14 would be the entire diagonal, and 92 would be the angle. 44, 44. See if this is 44, that's 44. Subtract that from 180. 180 minus your 88. And you get your 92, okay? 57, so this is 31. This one's also 31 degrees right here. And then you get 59 for this degree. Okay, there you go, from 90. 17 is diagonal, okay? That's easy. And then the angle is 59, okay? This is a square. So this is 1/2, this is 1/2. 90 degrees for a square. And then if it's 90 and cut it half, that's 45, 45. Okay, that's it for the homework. That was easy, okay? Now, again, I like this chapter. You know why I like this chapter? Because it's an easy chapter. I like the fact that we're into easy stuff. It's a great way to finish. So let's first of all talk today about trapezoids and kites. So I'm going to go to my journal first. Okay, let's go to my journal. Okay, so what we have is a picture of a trapezoid. So all we know about a trapezoid is this. A trapezoid just has, in fact, let's go ahead and turn the page. Let's just talk about a trapezoid. I want to draw a picture, okay? What is a trapezoid? It only has one set of parallel sides. Okay? And let me draw a picture of them, okay? So you can see it. Okay? Now we don't talk about a trapezoid that often because there's nothing really very special about a trapezoid at all. Honestly, there's nothing special about a trapezoid. So here is a basic trapezoid. I call it basic because if you look at it, and I drew it this way on purpose because I did not want to draw it as an isosceles trapezoid. So what I know, I only know one thing, that this side is parallel to this side, okay? All right? That's it. Okay? So that's a trapezoid. But if it's an isosceles trapezoid, then all of a sudden you get some cool things. So this is an isosceles trapezoid. An isosceles trapezoid, just like the word says isosceles, you're going to have the two legs. These are called the legs. A, B, and C, D are legs of trapezoid. They just call them legs. I don't know why they're called legs, but those are legs. And what we know about them is if they're equal, that's what makes it an isosceles. Okay, isosceles means two equal sides, just like an isosceles triangle. Okay, so that side's equal to that side. The legs are equal. Therefore, what happens when that happens is the base angles are equal. Base angles are equal. So that means angle A is equal to angle D, and even angle B is equal to angle C. Now they say base angles because, watch this little trick. Base means like bottom, kind of like base, but watch this little trick. Whoa, you're going to go, whoa, Mr. Davies, what did you just do? Turn it upside down. Now that's the base, okay? So base angles, all right? So base angles are the top or bottom angles, depending on how you draw it, okay? So what do we know? So if the base angles are equal, then we can say that it is an isosceles trapezoid. It's like the converse of it. So these are pretty easy. And so then what we get, if I turn the page, again, if it's an isosceles triangle, what else do we know? Well, also know that the diagonals will be congruent. So this diagonal is equal to this diagonal. So we can say that AC is equal to BD. All right, that's pretty easy also. If I turn the page back, which I will, and we take a look at the trapezoid I drew, a regular old trapezoid, if I drew in my diagonals, they are not equal. In fact, let me draw them in, you can see it. So again, there's not much special to a regular trapezoid. If it's a basic trapezoid, not much about it makes a whole lot of fun. These are not equal, you can see. But again, if it is isosceles, that's the key right now, isosceles, so that this side is equal to this side, then you can say the diagonals are equal. Base angles are equal. They're not bisected, but they are equal, and these other base angles are equal, okay? Now, if it's a trapezoid, plain old trapezoid, now look at this. This is not necessarily an isosceles, but we have this thing called a mid-segment, okay? So a mid-segment says this. If it's in the middle, how do I know it's a mid-segment? Middle, okay? Midpoint, middle, mid-segment, middle. So if M is a point in the middle, that means that this side would have to be equal to this side, okay? If N is in the middle, that means that this side has to be equal to this side, okay? Now what happens then is the length of this is the average of these two, okay? So I'll give you an example. So let's say I'm going to make some stuff up. I'm going to make some words up. Let's say this side is 8, and let's say this side is 12. Then all you got to do to find the length of this is you add them up and divide by 2, like an average. So we can say if I wanted to find M, N, I would go, all right, I'm just simply going to go 8 base 1 plus base 2 divided by 2, and it's just an average. So what's 8 plus 12 is 20. 20 divided by 2 is 10. Okay, see how that works? Okay, that's the mid-segment of a trapezoid. It doesn't have to be isosceles, so that would have actually worked over here too. We'd have the midpoints on this ugly thing. We'd have the midpoints, mid-segments, let's see, right about there, and right about there, okay. By drawing in the mid-segment, which I'll do right now, again, we can put some numbers in here if I wanted to. Let's say this side is 14. Let's say this side is, let's go along with, maybe I'm just making this stuff up, let's go 20. Then you'd say, okay, 14 plus 20 divided by 2, what's that, 34 divided by 2 is 17. Okay, so you got the idea? Alright, so trapezoids. One set of parallel sides. The mid-segment is the average between the bases, okay? If it is an isosceles trapezoid, two sides are equal, then you get base angles are equal and diagonals are equal. Okay, great. Now a kite. Kite's highly unusual because it is a quadrilateral, but kite's unusual because it's not a parallelogram, okay? This is not a parallelogram. So all the cool things about a parallelogram don't hold true. Opposite angles are not equal, except we're going to see that one set of them are. So if it's a kite, think about a kite that you fly in the sky. And I know when I build a kite, when I used to when I was a kid, that we knew the sticks went together at 9 degrees. So we know this about a kite, that the diagonals are perpendicular. Okay, I'm going to write that down. Okay, there they are. Diagonals are perpendicular. Okay, so right there, 90 degrees. That makes sense to me, and that's going to help me solve some problems later. I do know in a kite also that a kite has got two adjacent equal sides. So this side, this BC, has got to be the same length as this. For example, maybe this is 4 centimeters and this is 4 centimeters, and the same thing on this part of the kite. We know a kite has this shape. That might be, say, I'm just 7 and 7 centimeters. I'm just making these names up, okay? Now, opposite angles, well, if you look down here, it's only got only one pair. And here, those are the opposite angles. Angle B is not equal to angle D. You can kind of see it. That looks much bigger, that looks smaller. That might be, say, 80 degrees, and that might be 40 degrees. So they're not equal. But angle C, these bigger angles are indeed equal, okay? So I can definitely see, and I'm going to mark it, that angle A here is congruent to angle C, okay? I can definitely see that in a kite. Okay, now, That's what we know about trapezoids, regular trapezoids. We know about isosceles trapezoids. We got a clue about kites. So let's take a look at some notes that I put together so we can take a look at them. Okay? All right. Here we go. Here's a basic problem. It says find all the missing angles. Okay? First thing I do is like, look, wait a minute, there's not enough information here. I need more information, but I have enough because here's what I know. If it's a kite, I know that's 90. So let's draw that in. It's a kite. I know that I have a 90-degree angle. They cross at 90. Now that tells me quite a bit. So let's work this out one triangle at a time. So if I take a look first at this triangle here. Well, this is also 90. These two angles here have to add up to 90 because I've got 180 degrees in a triangle, right? So then I'm going to go, these two have to add up to 90. So to get angle, part of angle D here, we're going to go 90 degrees minus 24 degrees. Use my calculator. What is 90 minus 24? And I get an answer of 66. Okay, so this is 66 degrees. So because these angles are equal, then this is also 66 degrees. 58, this is also 58 degrees. Okay, awesome. Since these angles are equal, okay, 24, 24, because they're bisected. Okay, now let me look at this triangle in green. Okay, pretty easy. So if this is 58 and this is 90, we can get angle, part of angle C here. We'll just go 90 degrees minus 58 degrees, because that's 58 there. So I calculate 90 minus 58. I get an answer of 32 degrees. So this angle here is 32. This angle is 32. Okay. Now what I might ask on the test, which you need to know, is I might ask you for the measure of angle ABC. So check it out. I'm going to ask this question on the test. You need to know this. So if I ask for ABC, I'm asking for the entire obtuse angle, which is going to be my 66 plus my 58. And I'm just going to go, what is 66 plus 58? I get an answer of 124. I'm going to ask that on the test. And then I might also ask what BCD is. The measure of angle BCD is 32 plus 32, or 64 degrees. Okay, got it? Got it. Okay, now example 2. It says it's isosceles. If it's isosceles, then this side is equal to this side. Base angles are equal, so I know that this angle is equal to that angle. Okay, so I'm going to set them equal and solve. Okay, no problem. 10x plus 4 is equal to 5x plus 24. Base angles are equal. I'm just going to solve for x. Okay, base angles are equal, set them equal, minus 5x, minus 5x. I've got a 5x plus 4 equals 24, right? Minus 4, 5x equals 20. Divide by 5, x is 4. Okay, so then that's not the answer because we want to find all interior angles. We're not done yet. So I'm going to take my 4 and I'll plug it into either one of these. It doesn't really matter because they're equal. So maybe I'll plug it into that one. Okay, so I'll go 10x, or 10 times my 4 plus my 4, right? Gives me 40. Oh, that's not drawn. Oh, yeah, that's not drawn very well. Okay, that should have been down here. I have to change that because I can't. If that's 44, then my picture's wrong. But okay, go along with that. Say that's 44. Boy, oh boy, I got to fix that. That should be down there. Okay. So if that's 44, which does not look like 44, then that would be 44, okay? And then this angle here would be, how do I get that angle? Well, that's easy, because these two angles are supplementary, meaning they add up to 180. So angle A plus angle B equals 180. Okay, so I'm going to go 44, angle A, so I'll go 180 minus my 44 for angle A, 136. Mr. Lane's going to see that this doesn't make any sense, and he's going to tell me, but that's okay, Dave, I'll fix this, okay? These two angles are equal because it's a nice isosceles trapezoid, so that's also 136 degrees, okay? How did I do that? Okay, now, we know the trapezoid mid-segment theorem, okay? Again, here, last problem to do. We know if it's a mid-segment, then it's in the middle, right? That's a midpoint. That's equal to that. That's a midpoint. That side's equal to that side. We know then that this side plus this side divided by 2 equals that side. So let's just call it A and B. So A plus B divided by 2 is going to equal this mid-segment, which is MN. Alright. So we have a mid-segment, example 3. That's equal to that. That side's equal to that side. So we're going to take 2x plus 22. That's the one base, that's base 1, plus base 2, plus 6x plus 6, all divided by 2, okay, base 1 plus base 2. This base plus this base, all divided by 2, equals the mid-segment, so it has to equal 6x minus 4. Okay, so let's solve. I can do that. First of all, 8x plus 28 divided by 2 equals 6x minus 4. Alright. Well, I may as well divide by 2, but I have to divide both of them by 2. Divide. 4x plus 14 equals a 6x minus 4, right? Okay. Solve for x. Minus 4x minus 4x. 14 equals 2x minus 4. That's a 14, bad looking 14. Sorry about that. Plus 4 plus 4. 18 equals 2x, or x equals 9. Okay, now that is not the answer. That is not the answer. Because what are we trying to find? We're trying to find the value of x, yes, and then EH, FG, and MN. So I have to take my 9 and plug it in. I'm putting 9 there. I'm going to put 9 there for x. I'll put 9 there for x. Alright, I can do that. So I'm going to go 2 times 9 plus 22. I'm going to go 6 times 9 plus 22. And I'll go 6 times 9 plus 6. Oops, that's minus 4. How did I do that? Somebody say, Mr. Davies, you did that wrong. Fixed it. Okay, so then I'm just going to use my calculator, right? Me as well. What's 18 plus 22? This side is 41. Alright. 6 times 9 minus 4. This side is 50. And 6 times 9 plus 6 is 60. There you go. Okay. That's it. Okay, so homework. I have for you guys page 247, 1 through 7. Oh, let's check that out. Page 247. I swear I might have made a mistake, but that's okay. You guys will let me know. That plus that divided by 2, that must be a 40. That's got to be a 40. I don't know how I typed that in wrong. That has got to be a 40. Anyway, homework. Page 247. I'll show you what we got to do. It's pretty easy again today. So to show it's a trapezoid, you just have to find the parallel lines, and then on these you have to just figure out the mid segments and the other angles. Okay. So 1 to 7 all on page 247, 1 through 7 all. Okay, that's all I got.